All right, let's go. And fucking work kickball yesterday from basically 8 o'clock till later. Really 7 till later, but I stayed at work until then. Oh, so I'm now still fucking tired from yesterday. Okay, let's go. The wimping out. Okay, so last time we had some enumeration action, and we were converting enumerations into strings. I think the way that we were doing this. Let's see. So we had an enum. We would get a string from the user, and then we had a helper function that would return a standard optional, with the optional value being an enum, being the enum of choice. So it would return a standard optional either with an enum match, because the enumerators were in scope for that function, or well, didn't have to be. No, actually they weren't. It could have been in a different namespace, and we could still get the enums just by accessing the, what do you call it? The local scope, I guess, of the enumerator. Well, I guess it's not local. Their own scope, their own like namespace, I guess, is more of what it is. So we returned that, or null opt. So the null option, an empty standard optional with no value. And then in another function, we would. What did we do? I think. Did we say if it was null opt, then. Yeah. If it wasn't valid. So we had a function that would get input from the user, and then it would check it to make sure it's valid. And then let's see. So it got input from the user. It then checked to see if that. Well, I mean, I guess it took that standard string, and it checked to see if it returned a valid enum. And the point is that we had an enum, and then we were outputting it. So we had a function that would convert an enum. It was just a switch function, basically, a function with a switch statement that would convert the function, or would take an enum, and it would switch on the enum, and depending on which enumerator value it was, output the proper string. So the user would enter a string, we would store it as a standard string, we would check if it's valid. Well, I think I checked if it's valid, and then did I create an enum for the choice? I think that's what happened. Turn my fan on. Oh god, I'm so sleepy. Okay. Let me replicate it real quick. There's no point in rushing through this. I need to be fluent in everything in C++. All of it, everything. Let's get some music real quick. Looks like it could be good. Oh yeah, this should be on my watch later if it wasn't. Make sure I'm not getting copyrighted. Alright, we're good. Oh, it's real? Oh my god, she's fantastic. Just a killer singer overall. A lot of editing in her voice, but it's really good. Wait, what? No, I don't. Alright, so we'll do a little main function. Namespace. What do we want? Shop. Yeah, we'll do weapon shop. No, hold on. It's not, I'm not feeling it for some reason. Which enemy to attack? No. I guess we could do that too, technically. You could do an enum, but you would just do objects, I think. Yeah. Yeah, a little looping. Okay. Yeah, maybe the shopkeeper. Can we change enums? Are they dynamic? Like, can I later on come back and add another? I guess that's probably not a good. I guess that's what I did with the gun store, though. Or maybe you could, but you just lock down certain enums, like you can't access them at certain times. Or maybe you have an object, you have a class, and you say, not sure, a struct? A struct for an item, and then what, a struct for the shop, and then you call, and then you buy, and then you get, and then it... Do you have an array in it that lists all the items? You could. So what's a good use case for an enum? Well, it contains all the possible realities for something unique, something categorical, nominal. Maybe what, like like an attribute for a weapon? Like a weapon reach? Or weapon properties? Weapon... What would an enchantment or a feature of a weapon be? Like the has like reach. I'm thinking about like attributes you'd apply to a weapon in an RPG or something, like, or a tactical game maybe, where like a bill hook or something longer or a spear has reach, or it could have this or it could have that. Maybe like a Minecraft mod kind of thing. But the user's going to enter it. So choice, like a starter Pokemon was a good idea. Maybe, could have been. Well, not necessarily. Because then you could just output the 3 objects that exist, and each object is a Pokemon, and you just output the only 3 that exist, the starters, and then you just create an object of the one that exists. Or, well, I guess you just save that one or something like that. Let's do game difficulty. We'll say namespace difficulty. Or should we go ahead and put this in different files? I guess so, right? I think last time it was all within the same file. Yeah, let's do that, and then we'll work on getting it all linked to link up. I don't know, easy, medium, sure, we'll just do hard like that. It's easy enough. So we need this, we need a way of getting a string from the user. Or we could say input output. Need standard string here. We also need IOStream. We need output because we need to prompt the user. Or maybe that's character input. I think it is. Or okay, and we'll say function to get string. And it returns a reference to a standard string, but it would need to be if we call this to get a string. Is that the right play? Like, so what do we do? If we call get string, it's copying a standard string to where we are. Let's try. And we could do a string view for the prompt. We'll have a default initialized string view, and we can say if not, well, string view, or well, oops, we'll say prompt if prompt is that. We want to make sure that the prompt is not that. Okay, and then we'll just do see, this is the thing. A standard string, if I copied this and I passed it a standard string, we're creating a temporary variable on the trying to understand exactly the process by which we initialize a standard string here. I think the fuck all this temporary shit. The point is that I have to take a standard string and copy its value into this standard string. But in this case, we're fine. This is just a view to a C-style string, probably. But here, I have to I'm copying the value. There's the cost is the copy of this value. So it's not copies as in separate instances. It's copies as in data transfer. So one copy in, one copy out. One copy out. Because the user enters a string here, but then I'm copying it to initialize something. So I'm creating it, assigning value to a string one time, but then I'm copying it to something else instead of having it just get this. But I don't want to make this guy static, because then it exists at compile time and it's fucking up our memory usage. So, do I just handle it inside the same function that we do? So we get that, we get a standard string, and then we check, and then we pass a reference to it, and it exists, and I think we might. Yeah, let's just try and go for efficiency here. So we're going to do difficulties. We're going to say... we're going to say returning a difficulties. Get difficulty. Okay, and we're going to just prompt the user. Oops, this needs input output. And string. We'll do that for now. All right. Oh yeah, we need the different difficulties. Do I make them constants? Oh, I guess I could, huh? No, well, I can't make them constant expression. That's the problem. I can't make them runtime constants. Fuck. The problem is if I add another difficulty, I wish I could just like loop through them all. Would I just create them on compile time? I want to keep these end lines as separate as I can, so that readability is the best it could be. So I choose a difficulty. We list out the options. I mean, I could do 1, 2, 3. Excuse me. Or I could just leave it how it was. I don't think it's that bad. Okay, so we choose a difficulty, and then user difficulty. And then we can have another one called check difficulty here. We have a const standard string. It's const. It's going to exist in one spot. It's the same result as me including it everywhere. So I shouldn't make it inline and put it in it. Well, it doesn't need to be inline, but I shouldn't. Well, yeah, I shouldn't. It has internal linkage. If I added it in different files, these constants here, they would be unique and the linker wouldn't see them. But that's not really the point. I may as well just leave them here and then forward declare this whole thing, I think. They need a forward declaration to difficulty and the enum anyways, so. Oh my fucking god, this is a header file too. I was not doing this right, but it's fine. Don't need this. We do need difficulty. So do we say I think okay, so it's actually okay with that. I'm surprised. We include the enum. It needs to, its whole definition needs to exist in everything. So I think we just remove the enum from here. And then difficulty doesn't need the body. Oh, also true. Well, yeah, we're not returning yet, but it's okay. So these are the guys that are being defined elsewhere. And I could say extern maybe to... I mean, the forward declaration is the one that's extern. Do I want to say extern here? Just to show that, hey, these are able to be linked up. Yeah, because I don't think the linker will see these unless... Well... Does putting extern on this identifier make it publicly available? I guess the header file is not going to complain. It'll just say, hey, I see these extern forward declarations up here. They're defined elsewhere. And then they're actually defined in this file. I think that's okay. Okay, now let's finish this guy. With the string, we have a get line to get the string. Okay. We can check difficulty. So we could say while true. To continue getting difficulty until it's a valid difficulty. Or I think we do this first. That way we're not. Well, does the creation part matter? I'm just trying to think. If we create this each time, the creation of a standard, the creation of an object doesn't matter. It's the assignment to it. So I think this is the same. I think this is fine. We're going to validate difficulty, so we need a function that checks. So we need a standard well, let's see, do we need a standard option one? Or we could say convert difficulty string to enum. And then we can say another, or we actually do a standard optional. So in this case, we do need standard optional. So we need a standard optional, and it returns a hold. Do I want this? It's only in the header file. Okay, return a difficulties. That's how you spell difficulty? Oh my god, these words are not looking right. Return, oh, we're already in difficulty, so difficulties. I can't spell when I'm return that, and it's called convert difficulty, or well, difficulty string to enum. And it gets a string, so it gets a standard string reference difficulty string. And then we'll call it pass this guy a reference, and we'll say if difficulty string is and it already sees where difficulty options is, so we don't have to pass it. We could just say easy string. Oh, I guess we do have to do it's in its own namespace. Difficulty options easy string. We're not assigning it, we're just comparing. Then return difficulties easy. Else if difficulty string is difficulty options medium string, return difficulties medium. Else if difficulty string is difficulty options hard string, return difficulties hard. Else return nothing. Let's do standard null option. Return empty standard op. If invalid string. Yeah, true. I guess we only use it here, so may as well make them static, right? It's a good idea. And then this is going to be called elsewhere. Okay, and we're going to call difficulty string to enum, or we're going to say enum, or we're going to say, sorry, hold on. Oh, wait, here we go. Okay. Difficulties. So we're creating a difficulties test. Okay, and it only becomes like that once we get an identifier. I don't like that. Difficulties. User difficulty string. User difficulty enum. And we're going to initialize it by calling difficulty string to enum. We're going to pass it a reference to user difficulty string called. Oh, oops. This is a standard optional that is also a difficulties. And this is string. Oh yeah, and we have to dereference this guy. Or say .valid value. But then we also have to add in a check. Oh wait, hold. I guess I can, huh? Because if this returns as an optional, then I can do that. Same thing, really? Wait. Oh, I'm passing a fucking address of it. Okay, I guess I should pass. Wait, hold on. I should just pass it. Hello? Oh my god, I'm just being stupid. There we go. I was passing the address of it and not passing it by reference instead. I was using the ampersand, but it was wrong. And then we also need to say... Oh, no. Yeah, we have to convert it first. That was just a bad way of doing that, I think. Maybe not. Alright, so we first get it. Wait, no, hold on. Oh, wait, hold on. Oh, wait, I don't need to initialize it with the value, right? Can't I just... Yeah, I can initialize it with wherever... Really? I can just initialize it with the value? I don't even know what that would mean. That would mean that it's... I guess it would be fine, because it would be holding the location of where it is. But in this case, we want to give it the memory location of where the value is. So in this case, we don't need to do dot value. We don't need this extra parenthesis. So we just do this, and then we say if not user difficulty enum, then it's empty. Okay. Then continue. Or we can do this. We'll say invalid difficulty choice. Choose again. Continue. So we convert that to an enum. And then return something to convert the enum to well, I guess we just return the enum. Yeah. We just return user difficulty enum. But then if we want to print it, then we need to convert it. So it needs to be what, a void? Or are we saying, I guess we're getting the string, so we're gonna return, or do we want to return a string view, or do we want to actually if we're doing a C style string, I don't know if I want to just return that. So if I store the enum, I just want to print it, I think. So I think we just return it. So we'll do void print difficulty. And it takes a difficulties, user difficulty. And it's, we'll just switch. Or we could say, we could just return, do we return a string view to the C-style string? I guess I don't want to just call. I just want to. I want to be able to get the string. So maybe that's what we do. Standard string view. So let's say get difficulty as string from, or get user difficulty as string. Convert user difficulty strings to enum. And then we'll say convert difficulty enum to string. And then we can switch on the user difficulty. And then we can say case difficulties. Oops. Difficulties easy. Oh, oops. This is case difficulties easy. We can return easy. Do I want to return easy literally like this? I'd rather just return, oh wait, duh. Yeah, we just want to return a we want to return the strings, which are called difficulty options. So I forgot that the enum's not in here. So we'll return difficulty options. Yeah. Easy string. Yeah, and we don't need a break because we're already returning difficulties medium. Return difficulty options, medium string, case difficulties, hard, oops, hard, oops. Return difficulty options, hard string, and then default. Return, well, and what it's gonna say, all values. Yeah, exactly. Okay, makes sense. Default. What do we want to handle as our sentinel value? I guess we could make it a standard optional. Alright. Return standard null opt. Yeah, but the conversion really... No, yeah, it's fine, I guess. If the user entered it we have an enum, we need to get converted to a string. Or wait, no, we're gonna say difficulty enum to string. Invalid enum choice. This can be static. Invalid enum choice. Return empty standard optional. Invalid string. Return empty standard optional t. Okay. And I can initialize things to look at these string view. What was I passing via reference? Can't I just do a standard string view, right? And then I can just pass it. What was I passing? User difficulty? Yeah. And then I can just pass it via string view. That's fine. Difficulty. Constant difficulty options. So we can convert user difficulty strings to enum. We can get the user difficulty as a string. We can convert the difficulty enum to a string, so we can do a bunch of different stuff. So we can read it from the user. Read the string is from the, wait, what? But what are you talking about? Oh, because that hasn't been called anywhere, it's fine. Oh, well, yeah, I guess we actually shouldn't make it static. Because we're going to have to call that one elsewhere. We're not going to call difficulty string to enum, we're just going to call get the difficulty. Because this is how we would get one of those anyways. I think so. And then all we need is difficulty. And then we could say difficulties. Oops, hold. Oh, here we go. Difficulty. Difficulties. Game difficulty. We could make it const. Oh, do we want any of these functions to be const expression? And then we're not. I think so. I think we can here. What about hold? What? I fucked something up? Oh no, it's fine. And then get difficulty. We're outputting, so this doesn't evaluate to a constant, but this could also be a const expression too somehow, even though it's not gonna be, but it's fine. And this is a const difficulty called game difficulty, and it's initialized with difficulty. Get difficulty. And then we can output it. And this is returning standard string. Why do we want a standard optional? Because yeah, I guess we do. Because if we get an enum and it's not proper, I mean, we should only be calling it using existing valid strings. Or using existing valid enums, I guess. Because we call get difficulty and it returns a valid. It should be returning a valid difficulty. Oh. I love that I can pick my phone and it vibrates if there's notifications. Good. Where? Main? Oh. So I'm outputting. How do I want to return it? I want to return string view. I don't want to have to store it. I mean, I could just print it. I mean, do I ever want to store them, or do I just want to print difficulty? Void print difficulty. And we call this, and this gets the standard option. Yeah, that makes sense. Okay, so no parameters, no nothing. I guess we call it with a difficulties. Okay, and then we'll say and then we say so what do we create a standard optional then? So this returns a string view. Okay. And we'll call it difficulty string. And it's initialized with difficulty enum to string. And we call it with difficulty. And then we say if difficulty string dereference difficulty string else invalid difficulty. Oh, yeah, this guy needs a signature. Cool. Nice. This guy's not called anywhere else. Okay. These are the 4 declarations that we need in order to use these guys, so they're valid by the compiler because we're using these. We're using difficulty, and we're using those 2 functions. So we're using this guy. We're using well, I guess we aren't actually using difficulty options, huh? We're only using the enum and then getting it as a string and printing it. Hey, what? Get difficulty. Is that a bad name? Get difficulty enum from string? Let's just say get difficulty from get difficulty as string. Wait, did that automatically update? Hey, isn't that what I already get difficulty as string? Yeah, I guess so. Or oh, how about read? Get difficulty as string? Nah, sure. And what do we have up here? Anything redundant? We need the actual values. These are stored and we're just looking at them via string view. I mean, it doesn't matter if the string view is constant or not. I can't change it, I don't think. What happens if I tried difficulty string? Oh wait, but I think it can be reseatable. Yeah, 100%. Yeah, let's just make this not reseatable. Okay, we need to be able to convert a difficulty string to an enum to store it as an enum. And then we need to be able to get it from a string, and then we can convert it to an enum for storage. To store use difficulty as string. Right, use the difficulty to enum to store. Difficulty string to enum to store. Read use the difficulty as string. Well, let's just say get because it's really getting it from the user. Get difficulty from user as string. I don't like, yeah. I mean, I guess get user difficulty is fine. Or user difficulty. Because user difficulty doesn't, well, it does exist, but not really. It's not named the same. Convert difficulty. Oh yeah, this motherfucker said that I need to be louder. Louder! Alright, so. Oh wait, am I on, what am I on for recording? No, I'm on the record mode. Okay. This is actually getting it fully from the user. We could say get user difficulty a string. Let's do that. Get user difficulty a string. Get user difficulty a string. Excuse me. Difficulty enum to string. Print difficulty. I would almost like get used to difficulty from string, because I'm not storing it as a string. Okay. What's happening here? Why was it having a complaint? Oh, oops. Wait, what? Hold on. And what is this doing? This is saying difficulty enum from string. Wait, yeah, what? Did I type something? What is happening here? Hold on, it's calling. You get user difficulty from string. Oh, this is called from. Okay. Difficulty from get user difficulty. I don't like this from. Or we could say user string difficulty. Difficulty from user string. And then difficulty enum from string. Okay. Okay. I think that's okay. Alright. I need something else. Ooh. I gotta pee first real quick. Alright, so we did that. What was 12 or 13.4? 13.4 was to and from a string. So if it's to if it's to a string, we're getting it and we're wait, what are we doing? What the fuck? Hold to a string, then we're getting it as a fucking number. But I would want to get it from a string. So we could get a number in and store it as a string, and then convert the string by checking it into an enum. So the first step was just getting the enum from a number, but then it was getting it from a string. The reading part was easy because for both cases, the enum is the enum. So I either get an enum as an integer or I get an enum as a string, the harder part, because we have to do this if matching to make sure that it matches, and do standard optional to return nothing, and then check it before actually saving it. And then there's reading it as a string, which is simply just, or hold on, reading it from a string is checking, but putting it, so storing, hold on, from a string, but then there's, yeah, okay, so printing it to a string, printing the enum as a string is easy. It's a switch case, print the string. But reading it from a string means we have to check the string, and for each possible string, get the right one. And then, yeah, and then I would have to do to lower to include, to convert things to lowercase to match the enums being lowercase. All right, I got pee. Oof. Okay. Oh, fans, it's too cold. Okie doker. All right. We use the function to convert an enumeration into an equivalent string. So we have an enum. We have a string view. Yeah, exactly. Well, that part's easy. We're getting an enum to a string. We're just switching on it. What the fuck? Oh. It just looked weird because it was switch and then I guess I was expecting it to be indented or something. Jesus. Alright. Alright, let's lock it in. Hold on. Alright, we'll do some push-ups for a second real quick. It's not as much learning, but I'm kind of just exhausted. I gotta do something. I want to be even more exhausted, but everything is from kickball. One all-out sprint before the game, and I'm cooked. And I slice my finger out. GG. Oh. Alright, let's put it down. Alright. Let's do five negatives each. Okay. Okay. Alright, let's go. So, sure. Yes, we do that. And that's it. Easy peasy. Uh-oh. Hold. So we can make, oh, true, we can make a constant expression enum because they are symbolic constants. They're constant expression values already. We have to say your shirt is pass in shirt as an enum into the function. We have to remember the name of the function we created to get the enumerator name. Instead of just outputting the enumerator enum and doing it. That's kind of sick. It's almost like I'm thinking what is kind of sick is it's cool that we can apparently just change what an operator does. This section isn't too long, so I'm kind of surprised, but I guess it's kind of long maybe. Forget it depends on how many comments there are too. So if I can make it so I can just do standard character output and put an enum. Oh. Overloading the term just clicked. Overloading comma space. The term comma space just clicked. Oh my god. Overloading is multi-versioning. The fuck? Why did my window just bonk? I saw a thing a second ago, but okay. So function overloading is creating multiple versions of a function such that we can call it with a variety of different arguments of different counts and different types, as long as the overloads are able to handle it. If I have a double and an int version of an add function, but I call it with some new version, then it might not work. It depends. Is there an implicit conversion going on? Don't know. If we call it with a boolean, okay. Okay. A character, okay. A short, okay. We get promotion, or we get, well, yeah, we get promotion in that case. They just go to integers. But we call it with a long, oh, we're screwed, because numeric conversion from long to double, numeric conversion from long to int. Ambiguous. But if the same let's see. Yeah. So if I call a function with these arguments versus these, it's kind of like using an operator in this context versus this context. Calling add with, yeah, I guess operator overloading. Well, I guess it's not operator overloading, but it feels like it. It feels like the operator is overloaded when I do 3 plus 2 as I do a 3 plus 2.2, where 3 gets converted to 3.0 and then we get 5.2. It almost feels like there are different functions that are plus. It's just operator plus, and there's no, and it just takes two operands and we specify it, I guess, somehow. And, well, that'll be cool if we figure that out soon. And if you use it in one context, it does this. And if you use it in another context, it does that. I wonder if the conversion like that is a result of operator overloading. Why the conversion can happen, or if it is simply a language thing and it's just a phenomenon called implicit arithmetic conversion. I'm not sure. If it's operator overloading, that's fucking sick. Because then, like, hypothetically, I could have, if I wanted, I could have logic where instead of doing, I could basically, it's like, it almost feels like it's writing your own language. It's literally making your own syntax. Like, I could make the extraction operator if I make it binary, just like standard character output on the left. So we have an output stream on the left. And on the right, we have something that can go into an output stream, something that is output streamable. I don't know, something like that, something that's printable. An outputable thing, something that probably converts to characters, or an array of them, or something like that. Or maybe it is able to, maybe it converts it to a string and then outputs that, something like that. Or no, I guess it has to be characters, huh? It's probably converting it to an array of characters. That way it can shuffle through them and determine whether they're valid or not. Instead of just printing one whole object. Yeah, it definitely doesn't do that. Unless it steps through one whole object, but that still feels kind of funk. Maybe not, though. I don't know. But I could put custom, like, 2 characters. And if there's a character to the left of another character with the insertion operator to the left, the right-hand character attacks the left-hand character. So I could put, like, character X and character Y. I could say X and then insertion operator Y, but instead it becomes the attack operator. And then boom, boom. And then I could say Y, insert X. And now X is attacking Y versus Y, invert, or X, insert Y. Something like that. And maybe I do it both ways, where it's directional. Just like there's a left shift and a right shift, I can make it a right to left attack and a left to right attack. Doesn't really matter because I mean, it might might make a little bit more sense or be a little bit more readable in the code, but that's about it. Either way, it's like just pretend you only have left shift in bitwise, and you just say, oh well, I guess you would. No, not quite, because we don't have we have two different objects here, not like in bitwise operators where we only have one binary integer. I'm gonna get hungry soon. Maybe not. I had ramen and some leftover dinner from yesterday. Okay. So it's gonna be sick if I can take an operator and do some stuff with it. Like, would I want to do that in the little card game? Hmm. Yeah, I mean, I guess I could decrementing. So how does that work? If I can make it so that something that prints is able to print this. I'm not sure how it works. Okay. All right, let's go. So in this example, we have to know that there's a function that we have to call in order to get a string from a color, which is an enum. And it's just extra shit that we have to do instead of just outputting shirt. Excuse me. Wonder if overloading an operator has scope, so you overload it within a given context. Seems like you might, because that would be helpful. And then maybe you do that globally or constant in the file or somehow with like internal linkage so you don't overload the operator everywhere, only wherever the header file is included, maybe. Wait, I didn't even set up a start time. Hold on. Okay. Remember the name of the function created to get the enumerator name. And having to call it adds extra stuff. I mean, I don't think it's that crazy. I mean, you know that this is a shirt, but then maybe you have to remember you can't just output it straight away. I agree that it would be better if we could just extend this output. It's not like we're adding another name conflict thing. It'd be cool if we could teach this operator to output enumeration. So we could do something like this. So is it the insertion operator that's doing the conversion to a character then? And then we're just passing it to standard character output? Introduction to operator overloading. Oh, here we go. Unless in this we introduce function overloading, we create multiple functions with the same name Unique prototype. Cool. Yep. Variations that work with different data types without having to fucking do a different name for each one. Sure. Add double, add float, add long, add character, add boolean, add long double, add double double, add fucking. There's no double. Yep. Operator overloading. So we can make the operators work with our program-defined data types, huh? Basic operator overloading. Jesus. Define a function using the name of the operator as the function's name. So it's return a something, and then plus, and then a this, that. Add a parameter of the appropriate type for each operand in left to right order. Boom, boom. One of these must be a user-defined type, otherwise the compiler will error. The reason I'm guessing it would is because all non-user-defined types, so non-structs or classes and shit, the compiler already knows and has built in its core functionality what happens when you add any of the fundamental types. And there are only so many. Character, double, boolean, long double, long, int, maybe int 8t, int 16t, int 32t, int 64t, unsigned int, uint 32, uint 8, uint 16, uint 64, unsigned int, long unsigned int, long unsigned int, or unsigned long. There it is. Okay. Set the return type to whatever makes sense and use a return statement to return the result. Are you kidding me? And so do we do that and then we just convert the string? Is it that easy? When the compiler encounters the use of an operator in an expression and one or more is the user-defined type, it'll check to see if what? There's probably already a definition or an overloaded operator function. It does call operator functions. Oh my god. And those operator functions do the conversions. I could see a world where you have plus or int operator plus. Do we call operator plus or do we just say plus? Operator plus feels like it, maybe. Maybe not though. Plus parentheses or operator plus parentheses? It's gotta be operator plus parentheses, right? Int or int double. Then in there, excuse me, return static cast the int to a double plus the double one, and it's actually returned, so it should be double int double. The common types are already predefined in their things. And so it should be, yeah, I guess you could have double and then basically anything else, and then long double anything else, and then, yeah, and then the return type is long double, and one of the parameters is long double, but the other could be a template type. And then for an int, you could do the same thing as long as it's not floating, and it'll do it. But then for long, it has to be long, and for int, it has to be, well, but maybe you convert. No, because you convert ints up. So if you have an int and a long, right, it's going to numerically convert the int to the long to be wider. It's not going to convert it down unless you want to, because you get a narrowing conversion. Think, right? So if we say 5 or 4 plus 5, and then we just highlight this real quick. What's happening here? What are you bitching about? What if we say 4 plus 5 like that? Dang, I wanted to see how it would evaluate. I mean, I think that's what happens. It converts the wider. Okay. So if we say, here we go, enum Pokemon type, and we say fire, water, ghost, dark, only real types besides ice, dragon. Oh, they're all so cool though. Psychic is one that I forgot. Damn. All right. And then we say, oh, fuck. What's the return type though? Of the insertion operator. Oh no. So if it's called an operator function, it seems like the insertion operator is converting the shit on the right like a standard string Ethan, standard character output, insertion operator name, which is Ethan, as a string, standard string, or just string, whatever. What is it converting it to so that standard character output can take it? What if we say something different just to check? If we say a Pokemon type operator plus Pokemon type int. Oh my god. And now what if we just said plus? Yeah, not any good. And we say there's a Pokemon type and an int, and it returns fire. Int main. And then we say yo, yo, yo. Oh! You motherfucker. Hey, hey. Oh, I just can't. Wait, what? Oh, well, the problem is the initialization. Wait, I'm not even doing. Hold on. Fire plus 6. But really, this should be psychic plus 6. And then output test. And it should be fire. Oh my god, it is. Okay, we'll continue more in a little. I don't know what the fuck's going on here, but we'll find out. Basic operator overloading is fairly, that's cool enough. Alright.